All right, this is the final lesson in the similarity unit, and this lesson is called triangle proportionality. Now, the first half of this lesson should be easy. The second half is going to be a little more difficult, okay? But we'll get through it. So the first theorem we need to know for today is called the side splitter theorem, okay? It says, if a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. So if you look at this diagram right here, you have a triangle, and you have line EF parallel to BC. It means it never intersects BC. You can see that they're labeled with this symbol. That means that they're parallel. Okay? So the conclusion is that you can say AE over EB equals AF over FC. Okay? Sometimes that's easier than doing AE over AB equals AF over AC. Okay? It's called the side splitter theorem. Okay? So example 1, A and B, find the value of X. So as you can see in example 1A, we have this line BD. It's labeled as being parallel to AE. Okay? So we're going to use the side splitter theorem. I'm going to say 12 over X equals 16 over 4. In the past, you would have to do 12 over 12 plus X equals 16 over 20. But now we can use this little shortcut for this problem. Cross multiply, 16 times X equals 4 times 12. So 16 times X equals 48, X equals 3. Example 1B, find the value of X. We're going to use the side splitter theorem again. X over 4 equals 6 over 3. X over 4 equals 6 over 3. Cross multiply, 3 times X equals 4 times 6. 3 times X equals 24, X equals 8. Okay. So like I said, the first half of this lesson is not that bad. Example 2, find JG. So I'm going to use the side splitter theorem again because we know that this side is parallel to this side. So I'm going to do 20 over 30 equals 11 over JG. You can use X if you want and then use JG in the end. I'm just going to use JG right now. Cross multiply, 20 times JG equals 30 times 11. 20 times JG equals 330. And divide by 20. JG equals 16.5. Okay, now think back to Unit 2. We did converses. The converse is when you switch around the hypothesis and the conclusion. So the side splitter theorem that you learned on the first page, the converse is also true. Okay, so the converse says, if you know a line divides two sides of a triangle proportionally, then it means that you know the line is parallel to the third side. So if you knew that AE over EB equals AF over FC, then you can conclude that line EF is parallel to segment BC. Okay. Now we're going to take the theorems that we've just done so far today, and we're going to expand it a little bit into something known as two-transversal proportionality. And here we go. If you have three or more parallel lines, so in this case we have three parallel lines. See, these three lines are all parallel. If you have them intersecting two transversals, so this is a transversal, and this is a transversal, then they divide the transversals proportionally. So in this diagram, you can conclude that AC over CE equals BD over DF. Okay? Try example 3. Find LM. So we have three parallel lines. You can see these lines are labeled as being parallel. We have two transversals. So to solve for X, you're going to do solve for LM, you're going to do 8 over 6 equals 10 over LM, which is X. You can use the X if you want. I'll just use the LM though for now. 8 over 6 equals 10 over X. I'm just labeling that as LM. Cross multiply. 8 times LM equals 6 times 10. So 8 times LM equals 60. Divided by 6. LM equals 7.5. Divided by 8. Did I say that? 60 divided by 8. LM equals 7.5. Yeah. Next up, we have what's called the triangle angle bisector theorem. Okay. I'll try to make it easier when we get to the two examples I have on this problem. An angle bisector of a triangle divides the opposite side into two segments whose lengths are proportional to the lengths of the other two sides. Okay. So basically what you do is you look at the angle that's being bisected, or the angle that's being cut in half. Then you look at the side opposite that, put one of those parts over the other, equals AB over AC. So let's get to the example, try and make it easier, okay? Find the value of X, okay? So first, start with the angle that's being bisected, which is angle B, okay? Start with the angle that's being bisected. And then look at the side opposite that, and then put one part over the other. So I'll put X over 3.5. Remember, all your numerators have to come from one triangle, and all your denominators have to come from the other triangle. So my other numerator is going to be the side that's right next to X, which is 12. The other denominator is going to be the side that's right next to the 3.5. In this case, it's 5. And you're going to solve that proportion for X. So cross multiply, 5 times X equals 12 times 3.5. 5 times X equals 42. X equals 8.4. Okay. So as I said, this lesson gets a little hard in the second half. That was pretty hard. And it's going to get harder in the next 2 pages as well. Okay, so example 5, find SR and find ST. So first you have to find X, and then you can find those two segments. So we're going to use the triangle angle bisector theorem. Okay, so start with the angle that's being bisected. In this case, angle S. Look at the side opposite that and put one part over the other. So I'll put 7.5 over 12.5. Make sure all your numerators come from one triangle. Make sure all your denominators come from the other triangle. So for my other numerator, I'm going to put the side that's right next to the 7.5, which is x minus 5. For my other denominator, I'm going to put the side that's right next to the 12.5. In this case, x plus 5. Now, cross multiply. 12.5 times x minus 5 equals 7.5 times x plus 5. Distribute and solve for x. 12.5x minus 62.5 equals 7.5x plus 37.5. Subtract 7.5x on each side, and then add 62.5 to each side. You get 5x equals 100, and you get x equals 20. That's great, but now make sure you solve for what you asked to solve for. It says find SR and ST. So now go ahead and solve for SR and ST. Let's do SR first. It equals x plus 5. Twenty plus 5 is 25. Now let's do ST. ST equals x minus 5. So 20 minus 5 is 15. Okay. Now we're going to get to, by far, the hardest part of the lesson. Consider the proportion a over x equals x over b. In this case, the means of the proportion are the same number. Okay, see how the same number, in this case, they're represented by x, the variable. Whenever you have the same term in these two locations, that's called the geometric mean. That's called the geometric mean. Okay? Now, before we move on, let's talk about what an altitude is. In case you don't know what an altitude is. I'm just going to draw a triangle. An altitude of a triangle, it goes from the vertex to a side, and it's perpendicular to that side. Okay, so I just drew in the altitude in blue right there. That's called an altitude. An altitude goes from a vertex to a side of a triangle, and it's perpendicular to that side. Okay? I'll label it in blue. That's called an altitude. That blue segment, it goes from a vertex to a side, and it's perpendicular to that side. It's called an altitude. The altitude is the geometric mean of the lengths of the segments of the hypotenuse. Okay, so like I said, this is tricky. This is not easy, but this is what the next two problems are based off of. Okay, so the altitude is the geometric mean between the two segments of the hypotenuse, and the altitude to the hypotenuse of a right triangle separates the hypotenuse so that the length of each leg is the geometric mean of the length of the adjacent hypotenuse segment and the length of the entire hypotenuse. That is very wordy. Let's do some examples to try to make it sound easy. Okay. Okay, so find x, y, and z. Okay, let's start by finding x. Okay, so what you should know is that 6 is the altitude. Okay, 6 is the altitude. Okay, I just drew that in the last page. The altitude is the geometric mean between the two segments of the hypotenuse. So the altitude 6 is the geometric mean between the two portions of the hypotenuse, in this case, x and 9. The altitude is 6. That's the geometric mean between x and 9. So this is how you set it up. Cross multiply. 9 times x equals 6 times 6. 9 times x equals 36. X equals 4. Now let's solve for y. Y is called a leg. Okay, y is a leg. The leg, in this case y, is the geometric mean. This comes from the last page. I'm doing this based off of these two examples, right? These two sentences right here. Okay, the leg, in this case y, is the geometric mean between the part of the hypotenuse right next to it and the entire hypotenuse, okay? So the part of the hypotenuse right next to y is x, which we just established is 4. And the length of the entire hypotenuse is 13. Solve that for y. So multiply the diagonals. Y times y is y squared. That equals 4 times 13. So y squared equals 52. Think back to algebra 1. To solve for y, you take the square root of each side. And you only want the positive square root because we're not going to have a negative distance. Now, there is a way to simplify that, but we have not learned it yet this year, so I'm not going to go over that. So for right now, just get the decimal of that, do the square root of 52 in your calculator, and you get y is approximately 7.2. That's fine for now. We'll review simplifying square roots later in the year. And now let's solve for z. Z is a leg, so it's the geometric mean between the portion of the hypotenuse right next to it, which in this case is 9, and the entire hypotenuse, which is 13, because we know x is 4. 9 plus 4 is 13. Cross multiply. Z squared equals 9 times 13. 9 times 13 is 117. So z equals the square root of 117. And again, you can just get a decimal for now. That's fine for now. It'll be approximately 10.8. One more example based off of geometric mean. And again, this is not easy. Okay. Let's start by working with the altitude. The altitude is 9. The altitude is 9. That's the geometric mean between the two segments of the hypotenuse. In this case, u and 3. Remember, the hypotenuse is the side across from the right angle. So, cross multiply. 3 times u equals 9 times 9. 3 times u equals 81. U equals 27. Now let's solve for v. V is a leg. So it's a geometric mean between the portion of the hypotenuse that's right next to it, in this case 3, and the entire hypotenuse. The entire hypotenuse is 30 because we know that u is 27. So 3 plus 27 is 30. Cross multiply. V times v. V squared equals 3 times 30. So v squared equals 90. So V equals the square root of 90. You just want the positive one because we cannot have a negative distance. And you can just get a decimal for now, that's fine. V is approximately 9.5. Again, we'll talk about simplifying radicals later in the year. And finally, let's solve for W. W is a leg, so it means that the leg W is the geometric mean between the hypotenuse portion right next to it, which is U, which is 27, and the entire hypotenuse, which is 30. Because you know U is 27, plus 3 equals 30. Cross multiply, W squared equals 27 times 30. W squared equals 810. W equals the square root of 810. Get a decimal, approximately 28.5. So again, I know this is not easy. The ending to this lesson is very hard. Okay? Well, that's geometric mean. At least the first half of the lesson was easy. Right? And that's the end of this lesson. The lesson was called Triangle Proportionality.